Okay, today we're going to talk about functions for a little while. And first off, I want to get us a definition. So, a function is a relationship where every input has only one output. Every input has only one output. So, in other words, normally for us, we're dealing with x's and y's, and x's are normally the inputs, and y's are normally the outputs. So, normally we would have something like we were working with the other day, where we had maybe y equals 3x minus 9 or something like that. And we could say, oh, if I put in a 5, I get 15 minus 9, which is 6. So I only get one output. Okay. What if I put in 0? 3 times 0 is 0. Minus 9, I get negative 9. So this is actually a linear equation like we were dealing with the other day, but it's also a linear function. Okay. Now, the problem is we have to have some very specific ways to be able to tell if something is a function, because I could give you 10 examples of something that is indeed a function, but then suddenly, or every input gets one output, but then suddenly I could have just one little point or something, and all of a sudden I have two outputs, and now we're in trouble. Okay. So it kind of looks like this. Whenever we're dealing with our inputs, we call it the domain. And whenever we're dealing with our outputs, we call it the range. Okay, output. So domain and range is what we're talking about. And so if I had some kind of a little equation over here, let's say y equals x squared. It's one we use a lot. Okay, we will certainly use it a lot in this class. Y equals x squared. Let's put some points here. Okay, so if I put in 0, 0 squared is 0, so I get a 0 out. Okay, that's fine. If I put in a 1, 1 squared is 1, so I get a 1 out. That's fine. How about if I put in a 2? 2 squared is 4. I get one output there, right? Okay. But then we start talking about other stuff, like what about negative 1? Negative 1 has a 1 for the output, and let's do negative 2 as well. Has a 4, because negative 2 times negative 2, remember, whenever you put in negative 2 into a function, it goes like this. So it's parentheses. A negative times a negative is a positive. I get a 4. Okay. So what we see happening here is some of my outputs are repeating, right? But that's okay, because whenever I draw, this is called a mapping, the one input only gets one output. It's okay if this output also, or I'm sorry, this input also goes to that output. We don't care about that. What we care about is every time I put one thing in, I get one thing out. Okay. So y equals x squared is indeed a function. It's okay. Okay. And I could even do like a mapping like this, where I talked about, okay, this 2 goes to that 4, and this negative 2 goes to that 4. And even though the y's are repeating here, we don't care, because the problem would be if the x is repeating. Okay, so I got to watch out for that. I can't repeat the x. All right, so let's come over here and do a different one. And again, we'll talk about domain and range. And now I'll say, okay, how about y equals plus or minus the square root of x? So if you're not aware, every time we do a square root, when we put the square root in there, we put a plus or minus, right? So again, if I started with 0, well, 0 would be fine. 0 just goes to 0. So one input gives me one output. But when I do 1, okay, the square root of 1 is 1, but if I get a plus or minus 1, all of a sudden that one input Here's my input is getting 2 outputs, right? That's a problem. We see this split coming off. We say, oh, it's getting 2 outputs. That's an issue. And what about if it was 4? Okay. What's the square root of 4? Well, the square root of 4 is 2, but we also have a negative, right? So there's the negative square root of 2. I'm sorry, the negative square root of 4 is negative 2. Okay, so again, we see this branching out thing going on where 4 gets 2 outputs. So because it gets 2 outputs, it's not a function. Okay, and that's how we know the difference whenever we're looking at just a list of values or something like that. But we don't always get a list of values, so sometimes we have to deal with stuff. Okay, we have to play with it and see. So one of the main problems that we have here is if we're doing a square root or a fourth root. So up here, there's a little index number there. And whenever that's even, we're in trouble, right? That's when we're getting a plus or a minus. If that was a cubed root, or if that was a 3 up there, we wouldn't care. That's not an issue. All right. So we need to have a couple of examples, and they're going to be something like determine if the following is a function. Okay, but we're not always going to have just a list of numbers coming like what we just did. Okay, so, we got to find some ways to deal with that. So the first one is, I'll do this. I'm trying to put a little bit of paper here. So A is 3y minus 2x equals 3. Okay, and the B guy over here is going to be y squared minus x squared equals 9. All right. So as I look at this, I say, okay, well, I don't know anything until I get this guy solved for y. Because up here we had them solved for y, right? Y equals x squared, y equals plus or minus square root of x. We like to have them solved for y so we can see what's going on with the x's and stuff. So let's go ahead and do that. 3y equals, I'm going to add the 2x over, 2x plus 3. And then I want the y by itself, so I need to divide by 3, right? That'll go away. And everything's going to get divided by 3. So I get a y equals, this is going to be 2/3 x plus a 1. Okay, so that's just rearranging to solve for y. So that's my first step, solve for y. Okay. But then you're sitting here going, okay, can I tell if it's a function or not? And the way I can kind of tell is I can put some points in. Sure, if x is 0, that goes away. I get y equals 1. If x is 1, that's a 2/3. I get 1 and 2/3. So I feel like I'm only getting one output. But the real test is, do I see a plus or minus coming in there? Okay, that's one of the really big things that we watch out for in these is from the square, would get a square root and then it would be a plus or minus. Well, if you notice, these guys were only raised to the first powers, right? I didn't write them, but that's a 1 and that's a 1. So I'm not going to need to square root anything because there's no square going on. So that's nice. So when I look at this, I say, yep, this guy's a function. So the rule is solve for y and then check for repeating x values. Check if x repeats. And that means goes with more than one variable, more than one y. That's what we're checking for. Okay. So we kind of want to make sure we're looking for, I would say, exceptions, things that are going to cause me problems, right? And we don't have any of those here, so we're okay. And this guy is definitely a function. No worries. All right. But over here on the other side, we've got a little bit of a problem because whenever I look at this, I say, oh, I need to solve for y. So y equals, I'm going to add the x squared plus 9, but y squared equals. But now I see, hey, hang on a second. These guys, the y's are squared. So to get that y by itself, I need to plus or minus the square root of all that stuff on the right-hand side. So I would take the square root of both sides is what I'm saying. But because I'm putting the square root in, I also put in that plus or minus. And when I put that in, that's where I go, oh, hang on a second. This is going to give me two y values. There's going to be a positive guy and there's going to be a negative guy. Okay, so that's where I look at that and I go, oop, that's two outputs, not a function. And sure enough, if you put in an x value into this thing, like just right here, let's say 0, that's fine. 0 squared is 0 plus 9, that's 9. Square root of 9 is 3, but look, I get plus or minus 3. So automatically I've got two outputs. So that is not a function. Okay. The other thing you can do here is you can think about these graphs. Okay. This guy is a line. He looks, I don't know, something like that, right? And I don't really care where he crosses or anything like that. What I care about is he's a line and he's not vertical. If he was a vertical line, I would be in trouble, right? Okay, so if this was the equation x equals 3, well, that would just be 1, 2, 3, right? And I would put the x equals 3 there. That's a problem. Okay, that would be more than one y value. I would put in x equals 3 and I would get out a 0 and I'd get out a 1 and I'd get out a 2 and I'd get out 3 and all these things that are in between there, right? So this is what I got to watch out for. So no vertical lines. If you have a vertical line, that thing is not a function. But any other linear equation, which I know this is a line, right? Any other linear equation, those guys are just fine. Okay. This one's graph, because he's a square root, ends up looking something like this, right? And so that's, if you think about it, up here, here's my x-axis. This guy is the positive side of it, and this guy is the negative side of it. So when I look at that, I go, ooh, let's try again, x equals 3. Well, right here, I've got the square root of 3, and I've got the negative square root of 3. So I always get two values. So I can see that's definitely not a function. Okay. And what I just showed you there is actually something, it turns into a test that we use to kind of check, oh, let's check and see if that guy's okay, if he's a function or not. And most of my students normally know what this guy is. He's called a vertical line test. Okay, I feel like that should be a capital L, sorry. Vertical line test, and what it says is if a vertical line drawn anywhere on your graph touches in two or more spots, then it's not a function. Okay, not a function. So we have to be a little bit careful with this because it's got to be two or more, right? If it's 1 or 0, that's okay. So for instance, what if I had something like, here's my x and here's my y? And I don't know, I have a piecewise function. Those things happen, right? And it looks like that. And then it looks like that. Okay. So if I draw a vertical line anywhere on this graph here that hits one spot, one spot, one spot, be careful here where it's a piece because it hits this spot up here, but this one's open. So it's still just one spot and then one spot, one spot, one spot. So this guy's okay. We can actually say he passes the vertical line test. No problem. Okay. And also I could have something like, let's just do a pretty parabola. We've done these before. We've probably seen these before. Okay. That's for whenever we have quadratic functions. And again, I can draw vertical lines all through here, and I only hit once, no problem. Passes the vertical line test, no problem. But the one that maybe you'll see on a test or something like that kind of looks like this. What if it's this, for instance? Okay. Well, the trick is over here, I can draw a vertical line and I'm safe, right? So you have to be careful. This is what I was trying to say earlier. You can find spots where you're okay, on this graph. The thing you're looking for is the weird spots where you're not okay. So, like right here, if I drew a vertical line right there, I'd hit it 1, 2, 3 times, right? Right here. 1, 2, 3 times. And even say right here, I'm gonna hit it 1, 2 times. It's not okay. All I need is one spot where it does not work and the whole thing does not pass the vertical line test. So therefore, it's not a function. Not a function. All right. But this one's a function and this one's a function. Those are all good. Okay, but this one over here, not a function. Okay, so here's the deal. When you look at that and you think about it, really pay attention to the fact that whenever I've done these, all of this vertical line test stuff, students really like this method, but all of these vertical line tests require a graph. Okay, you have to have the graph. So, what does that mean? If I gave you this guy that we did just a minute ago, okay, either one of these, and I gave you the function, then I don't have the graph there, right? In order to, if you want to say this thing passes the vertical line test or it doesn't pass the vertical line test, you have to show me a graph. And here you would say it passes the vertical line test. Over here, you would say it does not pass the vertical line test. But you have to show the graph before you can talk about vertical line test. Otherwise, you're just talking about the equations, right? So be careful on that because occasionally somebody on a test will say, oh, yeah, it's a function because it passes the vertical line test. And you may even be right, but you didn't show me the graph and show me that it passes the vertical line test. Then you're not going to get full credit. So be careful. Okay. Good to know. All right. So the next thing after we do that is, well, we kind of want to talk about the domain and what's allowable and what's not. Okay. So the one that I mentioned earlier in the semester already was when we were talking about slope. If I'm dividing by 0, that's going to be a problem, right? Okay. So the same thing is true whenever we're talking about an equation. Okay. So the domain of a function is normally all real numbers, except when it has something weird happening. When it has something weird. That's a Webster word. That's not part of a definition. Something weird. Okay. Such as piecewise functions. Okay. If I have a piecewise function, like what I drew up here earlier, where it's in two parts, two pieces, then I'm going to be worried about what's going on with the domain here, right? So it skips on the range, but the domain is actually okay because it goes all the way up here to 0, and then it picks back up at 0 and goes all the way out here. And when I read these, I always read, like I said earlier, left to right. So that's what's going on with this. Okay. It's piecewise functions. Also, other weird stuff. You can't divide by 0. That's the one I mentioned earlier. Or take the square root of a negative number. Okay, so we're going to talk about both of those. So sometimes you have a piecewise function or something else that's going on that's weird. Okay, fine. We'll have to deal with that. We'll have to figure it out. But the two big, huge issues that we have with domain are when we try to divide by 0 or when we try to take the square root of a negative number. Okay. That's when we say, ooh, now we got issues in our domain. Okay. Those are bad spots. And those are the things you're going to have to look out for and really watch out. Okay. So that's up to you to go, oop. Anytime I see division where there's a variable in the denominator, oop, hang on. I can't divide by 0. And anytime I see a square root, or it could be a fourth root, it's any even root, but we normally say square. With an X inside of it, I go, oh, hang on, we can't take the square root of a negative number. So again, I showed you once one of these, but I will show you on your calculator. Can't divide by 0. Hopefully the calculator will convince you. Okay, that would look like something like 5 divided by 0. Okay, when the 0 is on the denominator, I'm sorry, I'm having a problem with my paper here. Okay, 5 divided by 0. Oops, hang on. Let me go back. 5 divided by 0. It gives me this error. And if you got a little bit more advanced calculator, it's going to tell you, you have an error, you can't divide by 0. Okay. You can either quit or you can go to where the issue happened and see. Okay. So that's one of the issues. That's an error. 5 divided by 0 is an error. It's undefined. Okay. And the other issue is whenever we can't take the square root of a negative number. Okay. So in other words, my example there could be like square root of negative 9. Okay. So whenever I go to do that, square root negative 9, I punch it on my calculator and it says, hey, you have an error. It's non-real answers. Okay. So what my calculator is trying to tell me is if I were to force this to have an answer, this is the same as square root of 9 times the square root of negative 1. And yes, we can take the square root of 9, that's a 3, but this square root of negative 1, I have a hard time with. It's because it's imaginary. So that's an I. So this is 3I, and that's a non-real number. Okay, which means it's not going to work. Okay, that's a bad spot in my domain. So whenever I look at that, my calculator, even if your calculator doesn't say non-real number like mine does, it should give you an error statement. And that's where you know, oop, I've got a problem in my domain. Something bad is happening here. Okay, so those two things I'm going to really keep an eye out for: dividing by 0, taking the square root of a negative number. Those are the two things that can always throw my domain into having problems, and we just want to watch out for those. We don't want to have any problems whenever we're dealing with some kind of a function and so on. Okay, so I have an example. Okay, my example is y equals x plus 2 over x minus 5. All right, so let's look at this guy. When I see this, what I do with it is I go to the denominator and I say, hey, denominator, you cannot be equal to 0. X minus 5 cannot be equal to 0. And I actually use this does not equal because that will work for me in a minute whenever I start talking about what my domain is, and I'll see it. Okay, so x minus 5 cannot equal 0 because, again, I cannot divide by 0. And you have to be careful about that because some people will say, oh, x can't be 0. Actually, x can be 0 here because 0 minus 5 would be -5 down there, and I can divide by -5. I cannot divide by 0. So what I have to do is take the entire denominator and set it does not equal to 0. That's what I'm doing here. Okay, it's got to be the whole denominator. Okay, and then I just solve for x, right? Okay, so now I say, hey, I got to add a 5 to both sides of this guy. I know it's a does not equal instead of an equal, but normally most of those things work very similarly, and that's what happens here. I add to the left a 5, I add to the right 5. X cannot equal +5. That's what I got. And sure enough, so I'll come back to how I look at that in a minute. But sure enough, if I put in a 5 right here, 5 minus 5, that would be 0. And I'd be dividing by 0. I cannot divide by 0. So we know that's correct, right? I can't have x be a 5 there because that's a problem child. Okay. So now, what does this tell me? All right. There's a couple of different ways you can write this. You can say it's all real numbers except x cannot equal to 5, okay, because we know it's supposed to be all real numbers, but that's my problem child, so I'm going to kick him out of the domain, okay? Or you can use interval notation, and this is how most of the time we ask for it. So like on a test or something, if you see hey, give me interval notation, that's okay. What it means is we're going to look at this as if we're coming left to right. Let me stick this guy on my calculator and see if we can see what his graph looks like. Okay, so y equals, on the top I've got x plus 2. He's in parentheses because that's the entire top, divided by, on bottom I've got x minus 5, and he's in parentheses because that's the entire denominator, right? And let me graph him and see what's happening. And what you see is this turns into basically a piecewise function, right? There's this part that's going down like this, and then there's something we call an asymptote, well, that we'll get to later. And then there's a part like that, okay? And what's happening is right here at x equals 5, that's where that asymptote is. And basically, it's causing my graph to split up, okay? So looking at my domain and from left to right, I start out here at x equals -infinity, right? And domain is always on your x values or your inputs, okay? So I start out here at -infinity, and I'm good all the way here until I get to -5, and then all of a sudden this guy shoots down, okay? So because there's a problem at x equals 5. And then just barely on the other side of x equals 5, it starts up here and it goes all the way back out here to +infinity. So I have two pieces, and I need to reflect the two parts of the graph in my interval notation, okay? I'm going to talk about both of them. So first, let's talk about this guy from the left. He starts at, again, the x values start way out there at -infinity, okay? And it kind of ends up looking a little bit like point notation, but it's not, okay? You either have a parenthesis or a hard bracket, okay? And I'll show you a hard bracket in a second. But the parentheses happen for things that I don't actually touch, okay? And the idea here with putting a parenthesis with a -infinity is you're never actually going to touch infinity, right? Okay, or -infinity. It comes all the way up to 5. There we go. It comes all the way up to 5 here, and then 5 is a bad spot, and we skip it, okay? So, again, we're not gonna touch 5, so we put a parenthesis, and we put what's called a union symbol. This means or, O-R, and then we start back up at 5 because it's just a momentary little gap there at 5, and we come all the way out here to the right, and on the x values, that is +infinity. Okay, so that is what my interval notation would look like. All right. And I use parentheses for things that I would not touch, okay? If I had some kind of a weird graph like, oh, let's say, let me just give you a graph so you can see it. Okay. And we're just going to say it starts here at 1 and it just shoots that direction. Okay. If you wanted to do the interval notation on this, you go all the way to left on the x values, but there's not anything, there's not a piece of the graph out there. So the farthest left is actually 1. That's where my domain starts here in this case, right? So it's a separate example. Okay, so don't it's not the same as what's up above, so don't get them confused, okay? So I start here at x equals 1, and it's a solid dot, which means it's included, right? So in that case, I use what we call a hard bracket. I start at 1, and how far to the right is this going? All the way to infinity, Dr. Webster. That's what I heard. And again, because it's going all the way to infinity, it's a parenthesis there, right? It's not a solid bracket. So it starts at 1 and it goes up. All right. So that's an example of when you would use a hard bracket. We always use parentheses on the infinity, but sometimes the actual numbers in here kind of in the middle, sometimes they have parentheses like this 5, sometimes they have hard brackets like that 1. All right. So there's you an example of when you would use that hard bracket, just so we can see it there. Okay. So anyway, that's what it would look like when I can't divide by 0. I'm going to find the spot that or spots that make the denominator 0. And I'm going to say, hey, I can't have those. Those are bad spots in the domain. That's Dr. Webster's bad spots in the domain. That's what I call them. Okay. And so it's an issue, right? It's either causing me to divide by 0 or square root of a negative number or sometimes something else that's kind of weird. But we're going to stick mostly with dividing by 0 and square roots of negative numbers. So that's how I would do that. All right. And then tell me what your domain is, either in words or interval notation. Most of the time we stick with interval notation. Okay. How about a square root guy? So that was dividing by 0. Let's get us an example where we've got a square root. Let's do x squared minus 5 equals y squared. Yeah, those are my bad spots in my domain. Okay, so here we go. We're looking at this guy and we're going, let's take the square root of, actually, I'm sorry. Let me you do a slightly simpler problem over here first, and then we'll come back and grab this guy. So ignore him for just a second. I'm sorry. I just want to get the idea first before we get this little bit more complicated problem. Y equals the square root of x minus 2. See my covering method there? You can't see it. You can't see it. It's not there. Square root of x minus 2. Okay, so again, I'm looking at this guy and I'm going, wow, the issue here is this thing in here cannot be a negative number, right? That's where my problem comes in. So again, I do a similar thing to what I did earlier. And I just pull this out of there. I say x minus 2. But here, instead of cannot be 0, that's not what I'm after. Actually, it can be 0 up in there, right? 2 minus 2 would be 0. And if I took the square root of 0, I would get 0. That's okay. It would be something like 1 minus 2. That's the problem. 1 minus 2 is negative 1. Square root of that, now I'm in imaginary numbers. So that guy's not going to give me a real number. So instead of does not equal to 0, like I did earlier, I say, hey, it has to be greater than or equal to 0. So the equals just means 0 is okay. But the greater than, what numbers are greater than 0? positive numbers. That's what I hear in my head. Positive numbers are greater than 0, so that would be okay. So now again, don't worry about the fact that this is greater than or equal to. Hopefully you've seen some inequality stuff in the past and you know how to deal with inequalities. There might be some of that kind of finer points in your homework, but I'm not really going to deal with them. What I'm going to say is, generally speaking, they work just like an equation. So I'm going to add 2. X is greater than or equal to 2. That's what I'm looking for here. Okay. And again, the only thing, well, I haven't said it yet, but the only thing that's a problem here would be like if I needed to multiply or divide by a negative number, I flip the sign there. And if you don't know exactly what that means you need to go do some work with inequalities and see what's what. Okay, so I think there's a review in your homework somewhere probably where you have to deal with that. Okay, x is greater than or equal to 2. Okay, that means we're starting here at 2. And I had a student once who said, it's like it's equal to those equal to signs, and then you just connect it, right? So greater than or equal to means start at 2, and what numbers are bigger? 3, 4, 5, 6, all the way to infinity, right? Okay. So what this is telling me is, hey, you can put in 2. 2 is okay. 2 minus 2 is 0. Square root of 0 is okay. Or you can put in a bigger number. So let's try 6. 6 minus 2 is 4. Square root of 4 is 2. No problem, right? Okay. So where I'm going to have a problem is, again, if there's a plus or minus out there, it's not a function. Or if I'm looking at the domain, I got to worry about what's inside of that square root. Okay. So now let's come back over to this problem. So I hope everybody's okay with that. We'll have a couple of things in the homework about it, I'm sure. This one kind of combines both things. I want to know, is it a function? And it's not. And hopefully you already see that. But you should kind of say, ooh, I would want to take the square root of this guy. And when I do that, I need a plus or minus, right? So y would equal plus or minus the square root of x squared minus 5. So that's a problem because it's not a function. So right off the bat, we don't have a function. And then you say, okay, I want the domain of the function is what it says, but because it's not a function, there's not any domain. Okay. But you could still take this guy and look at him just for fun. Let me pull him out. So no domain because it's not a function. Let me pull this guy out of there and let's see what would happen. X squared minus 5 has to be the greater than or equal to 0. I just want to talk about what's happening here, even though this guy's not a function. Um, to solve this guy for x, I would do x squared is greater than or equal to 5. And then I'd look at that and I go, hang on a second. Whenever I need to do this, I need to square root both sides. And I need a plus or minus, and x is greater than or equal to plus or minus the square root of 5. And now I've got weird stuff happening here, right? It's greater than the positive square root of 5, or it's less than that. So it's really kind of a mess. So that's why we don't deal with that normally. You would just say, hey, let me say it's not a function, and we can stop there. Okay. Let's look at one more of these with a square root, and we'll move on. Okay, how about y equals the square root of 3x minus 4. Okay. Again, what we're worried about here is can't take a square root of a negative number. So we need this to not be a negative number inside of there. So I pull this guy out. I say 3x minus 4 is greater than or equal to 0. Okay. You're either dividing by 0, so it's saying not equal to 0, or you're taking a square root and you're saying greater than or equal to 0, right? Okay. And then 3x is greater than or equal to 4. X is greater than or equal to 4/3. Oh, that's nice for me because it's a nice, pretty number. This guy has the equal sign in it, so I'm going to start at 4/3. And it's greater than or equal to 4/3. It's bracket because it's equals, but greater than takes me all the way to infinity. Okay. Hopefully that makes sense. All right. So there's something else that they're going to want us to probably do in here, and it's called evaluating functions. So once we know something's a function, okay, now we might need to put some points in and do stuff, right? So it's going to look something like this. And we're going to evaluate. So see that word value. Okay, we want to value whenever we plug something into this. So it'll say something like, here we go. Part A, if f of x equals 12 over x minus 2, find f of negative 2. Okay, so what this means is it's supposed to be, I'm sorry, I don't think I mentioned the function notation, so let's get that out there. The way I read this is I have a function and the variable that's in it is x. Okay, so a function in terms of x. And sure enough, when I look inside of this guy, it's got an x in there. And the nice thing is it's actually telling me, hey, this is a function. You don't even have to try to solve it and figure out if it's a function. I'm telling you it's a function. But then we go in and we go, okay, it was an x in there, but they're telling me find f of negative 2. Okay. Literally what that means is go back here where you saw that x. Here's the x. And plug in a negative 2. Okay. So this becomes f of negative 2, because I'm plugging in negative 2, equals 12 over, and it's a negative 2 minus 2. Okay, because the minus 2 was already there. So I'm plugging in negative 2. So that's just 12 over negative 4, right? Minus 2, and then I go minus 2 farther down the thing. So that is 12 divided by 4 is 3, and a positive divided by a negative is negative. So negative 3. All right. B. B says find h of negative 8 if h of x is the square root of x minus 1. Okay. Again, wherever I see an x, I'm plugging in a negative 8 now. Okay. So h of negative 8 equals the square root of, it's going to be negative 8 right there minus 1, right? So this is the square root of negative 9, okay? And this is what I was talking about earlier, that sometimes we have to deal with imaginary numbers, okay? This isn't telling me whether or not this is a spot in the domain that's bad. They actually asked me to just find a value, right? So I'm just going to plug that in. And like I did earlier, I'm going to tell you that's the same as square root of 9 times the square root of negative 1. And the square root of 9 is 3. And the square root of negative 1 is I. So that's an imaginary answer, but it is an answer, and they asked me to find a value. So that's what I've done. So we are good to go. Okay, and then part C says, find f of 3 over h of 5. Now I got to go plug into different things. So let's come back. F of 3, so that's this original function. That's going to be 12 over 3 minus 2. What's that? 3 minus 2 is 1. 12 over 1. Okay, well, that's going to be just 1, right? Divide by, and here's my h function. So let's stick that in. Square root of h is, or x is 5 minus 1. Well, what's that going to be? 5 minus 1 is 4, right? So this is the square root of 4, but we know what the square root of 4 is. Square root of 4 is 2, right? So I've got 12 over 2 or 6. Okay. So any of these that say evaluate, you're actually finding an honest to goodness value. Okay. You're going to just plop that guy in there and see what you get out. What value do I have whenever I finish this? That's what we're after. Okay. All right. I think this is maybe the last topic in this, so I might go back and pick up a couple of, yep, this is the last one. I might pick up a couple of sample problems to say, hey, did we do this right? Did we do that right? But let's take a look at this one. There's something that's called a difference quotient. Okay, and this guy will actually come back around to do some stuff for us whenever we start dealing with derivatives whenever we get to calculus end of things. So we're going to deal with it in the algebra sense, but he will be back around. Okay, so just so we know, the difference quotient is f of a plus h minus f of a all over h. Okay. So what we're going to do here is we're going to say, oh, how do I do a plus h? Okay, so let's get an example. If I tell you my functional value is 3x plus 5, I'm actually going to do this in several steps at a time. And in fact, your book calls it the 4-step process. Okay, so I'm going to do the f of a plus h stuff. This is one step. I guess at this point, we're actually doing 3 steps. Okay, and then I'm going to subtract this guy. That's the second step. And then I'll divide by 3 or divide by h as the third step. Okay. So first up, we've got to figure out what we can do with f of a plus h because that's a little bit different. Okay. And this is actually the step that bugs the most people is this substitution. So remember what we said. Earlier we had an x, now we're putting in an a plus h. Okay. So over here, everywhere that I see an x, I'm going to put parentheses. I'm going to put in a plus h. Okay. So this turns into 3 times parentheses a plus h plus 5. Okay. And we can't be done until we finish cleaning up this up as much as we want, as much as we see we can. And by cleaning it up, I just mean simplify it, make it so that I've done as much math here as I can and it looks as pretty as I can make it. So in other words, I can multiply this 3 through, distribute it, 3a plus 3h plus 5. Okay. That's what my f of a plus h looks like. Okay. So that's the first step. That's just this. Okay. And then, so let me put I'm going to put a 1 here. Okay. Then the second step is subtract off the original function. So it looks like f of a plus h minus f of a, and notice that they're plugging in the a there. And I'm going to do that. So it's going to be the f of a plus h. We just found that. So that's nice. 3a plus 3h plus 5 minus, I'm going to subtract off the function. I hope you'll put parentheses so that you can distribute that negative sign through. And instead of the a, x, we're going to put an a, right? Because it's f of a. So 3a plus 5. Okay. But the trickiness here is this minus goes all the way through. Okay. So whenever I look at that, I say, well, this is 3a plus 3h plus 5 minus 3a minus 5. All right. And then here's the cool part about the difference quotient. If I did it right, most of my stuff that doesn't have h's in it will go away. Okay. So 3a minus 3a, those are opposites. That's a 0, right? And what's a positive 5 minus 5? Those are also opposites, and that's a 0. So what I get out of this guy is just 3h, right? That's the only term that's left hanging around. So for step 2, what I got is 3h. Okay. And then the last step, step 3, it just says take whatever you got up above and divide by h. So what I got up above was just 3h. Divide by h. The h's will go away. That's just a 1, right? And 3 times 1 is 3. Okay, so I did a lot of math in here. I did a lot of work, the f of a plus h, the minus f of a, all divided by h. And I end up with a relatively, simple answer. It's not crazy and in depth like it started out with. Okay, so FYI, there we go. Okay, so that's the difference quotient. The nice thing about this example I gave you was look at this guy. He was x to the first. That was nice and pretty and linear, right? Okay, so we're going to do one that's not linear because sometimes weird stuff happens and I want you to see it. Okay, so I'm going to give you, your next example is x squared f of x equals x squared minus 2x plus 7. Okay, so x squared minus 2x plus 7. And we're going to do the same thing. We're going to find the difference quotient. Okay, f of a plus h minus f of a all over h. Okay, and again, the first step here is doing this f of a plus h thing. Okay, that's second step. This is the third step. Okay, so f of a plus h. But hang on a second. Whenever I go to put in f of a plus h, everywhere I see an x, there's a couple of spots here for the x, right? There's an x squared minus a 2 times an x plus a 7, right? So there's 2 different spaces here that I need to put that a plus h guy. Okay. And probably one of the toughest steps here for a lot of people is this a plus h. The first one is being squared, right? So we're going to play with that in just a second. So that's what it looks like whenever I put the a plus h's in. Okay, a plus h squared minus 2 times parentheses a plus h plus a 7. Okay, so let's deal with this. A plus h squared. Remind me what something means whenever I square it. What does that squaring mean? If it was 2 squared, you go 2 times 2, right? Okay, so here it's a plus h squared, so I'm going to go a plus h times a plus h. So something squared, ignore the rest of that stuff. Something squared is just that thing times itself, right? If I said 5 squared, you'd go 5 times 5 and you give me 25. Okay, so that's a plus h squared. This is the rough step for most of my students. If they have problems, that's where they're going to have problems on this. So it's an algebra step, so watch out for that. Okay, I'm going to distribute this negative 2, negative 2a minus 2h plus 7. All right. And then if you need to go off to the side to figure out how to multiply these guys through, these binomial times a binomial, but a times a is a squared. It's called FOIL, if you remember. First times the outside guys, inside guys, and then the last guys. So a times a is a squared. A times h is plus ah. Okay, that's the outside. This guy was the first. This guy was the outside. These are the insides. A times h, so that's again AH. And these are the last guys. So if you don't remember FOIL, again, go back and do yourself a little bit of work with that and make sure you're all up to date on that. So h times h is an h squared. Okay, there is my f of a plus h. So that one's a little bit longer than the other one was, and it takes more time. So just FYI. Okay. All right. Step 2, subtract off the original function with an a in it. So it looks like this. F of a plus h minus f of a. It's all this stuff. A squared plus, I'm going to call this AH plus AH, 2 AHs plus an H squared minus a 2A minus a 2H plus 7. Okay, so that's all F of A plus H minus the original function was x squared. I'm going to put parentheses. I'm going to make that A squared minus 2. I'm going to make that x and A because it said plug in an A, right? Plus 7. All right, there we go. And then one more time, you better put those parentheses there because most people miss this negative. So that's where, if we have issues, it's somewhere right here at the beginning. It's not toward the end. Okay, so minus a squared, negative times a negative is a plus 2a, and minus 7. Okay, now look at what happens here. I've got a positive a squared and a negative a squared. Those are going to go away. A squared minus a squared is 0. I've got a negative 2a and a positive 2a. Those are going to go away. Negative 2a plus 2a is 0. And I've got a positive 7 and a negative 7. And 7 minus 7 is 0. Okay. So once again, I'm telling you, look at this guy and see what we've got. Okay. The only terms that are left that didn't go away, they didn't reduce out or cancel or however you want to say it, these terms have h's in them. 2ah plus h squared minus 2h. They all have h's in them. Everything else goes away. And that's how this should work for us. So hopefully it ends up being okay. So that's step 2. And then coming back here, we said, where was it? Oh, here it is. Sorry. We said step 1, subtract step 2, divide by h is step 3. So step 3 here is take this guy, whatever we have, divide it by h. 2ah plus h squared minus 2h all over h. Okay. Now, I know some of you want to just start marking out h's, and that's fine as long as you're really careful with it. But some people don't understand what happens with this h squared guy. And it's really important that we get that guy and we get this guy figured out. So what I'm going to do is instead of just marking stuff out, I am going to factor that h. I see an h in all 3 terms. So I'm going to pull the h out of here, 2a. I'm going to pull an h out of here. Now, what's h squared mean? H times h, right? So if I pull one h out, there's still an h left in there. And here I'm going to pull out an h, and I'm going to say minus 2. Okay. And before we go on to do the rest of this, look at that and say, is that the same as what we just started with? 2ah, yep. H times h, h squared, yep. H times negative 2, negative 2h, yes. Okay, so yes, it is the same stuff we started with. And then, hello and behold, I see, hey, look, those h's will divide. H divided by h is just a 1, right? So what we've got left over here is 2a plus an h minus a 2. And that is your final answer. So some people don't love this because it's a little more complicated. It's an x squared guy, right? So he takes a little more time. But if you're really careful with him, you'd probably be okay. All right. Everybody okay? All right, I've got one more to give you, and you can work on it on your own, and then I will just work it real fast. So if you want to push pause, then go ahead and push pause. It says find the difference quotient. And your function is f of x equals negative 5x minus 10. And I'm just going to say there's a lot of negatives in that, so watch out for it. So you go ahead and push pause. I'm going to put over here difference quotient equals f of a plus h minus f of a all over h. Just to remind you, again, if you write it every time you do one of these problems, you will probably be okay. All right, and you go work on it and then come back here, push pause, and I will very quickly run us through it. Plugging in my a plus h. There's my answer for that step. Subtracting the a, f of a, I mean. If you're subtracting it, you sure better put in those parentheses so you know both of these are going to change signs, right? So I'm going to distribute that through. Negative 5a minus 5h minus 10 plus 5x. Oh, I'm sorry, that was an a. I didn't plug in my a. And then plus 10. And hopefully if we did it right and I substituted in my a where my x's were, all of those guys go away, right? Negative 5h. And then the last step here, divide. Sorry, whenever I tell you to do it on your own, I tend to run through it pretty fast. Just so that you can pause. Oops, sorry. You can pause and go do what you need to do. I'm getting a negative 5. All right, so hopefully you're back by now. You did that problem by yourself. I'm hoping you got a negative 5. If not, look through how I just ran through it pretty fast, but hopefully it gives you a step to see what you're up to. And that is the end of that section. All right. Let me know if you have questions.